Secure audit trails turn agent activity into evidence. They capture who acted, what happened, when, why, and with what outcome, then protect those records from tampering. In this section, we'll design logs that support accountability, compliance, investigations, and response. So far, we've identified agent risks, designed practical controls, and gained observability across events, traces, metrics, and logs. Now we make that visibility accountable. Secure audit trails preserve trustworthy evidence, so teams can monitor activity, investigate incidents, review decisions, and continuously improve their security posture. An AI agent rarely acts in one place. It may combine a prompt, stored memory, retrieve documents, tools, APIs, and approval steps before taking action. That chain is powerful, but it also creates risk. If something goes wrong, you need to know what the agent saw, what it decided, which tool it used, and who approved it. A secure audit trail turns that activity into evidence. It supports incident investigation, compliance reviews, user accountability, and governance. In practice, agent logs are not just operational telemetry, they are security records. Logs are not interchangeable. Debug logs help developers troubleshoot variables, trace flow, and errors, often for a limited time. Observability logs help operators understand latency, reliability, performance, and system health. Audit trails serve a different purpose. They answer who did what, to which resource, under what approval, and with what outcome. Because they may support investigations, compliance, or legal evidence, they need stronger retention, access control, tamper resistance, and integrity guarantees. The purpose determines the controls. Treating all logs alike creates blind spots, unnecessary exposure, or both. A reliable audit trail starts with a repeatable question set. For each meaningful event, capture who initiated it, the context they were in, the action attempted, the resource touched, the policy decision made, and the result. The core record should include identifiers such as session ID, request ID, timestamp, action type, resource, and outcome. For AI agents, also include model used, prompt context reference, tool invocation, and policy decision. When every system emits this same shape, logs become searchable, correlatable, investigable, and actionable. Accountability also depends on linking activity across the full request path. Capture the actor clearly: a human user, service account, agent role, or delegated identity. Attach session and request identifiers, including session ID, request ID, trace ID, and correlation ID, so distributed logs can be stitched together. Add tenant, workspace, environment, and application context to avoid confusion in multi-tenant systems. Finally, preserve delegation chains, such as user to agent to tool service, because that chain explains responsibility from start to finish. Tool calls deserve extra audit detail because they cross a security boundary. It is not enough to record that the agent used a tool. Identify the tool, version, endpoint, permission scope, and runtime environment. Capture sanitized arguments, validated parameters, target resources, and resource IDs. Just as important, log the decision context: why the tool was chosen, whether policy allowed it, and whether approval was needed. Then record the outcome: success or failure, error codes, output summary, side effects, and rollback status. When an agent requests a risky action, the audit trail needs more than the final result. It should capture each decision point: whether policy allowed, denied, escalated, modified, or rate limited the request, and whether human approval was requested, granted, rejected, expired, bypassed, or overridden. For approvals, record who approved it, when, why, and under what conditions. Most importantly, link that approval to the exact agent request and tool action it authorized. That linkage turns a vague permission into defensible evidence. This person approved this action for this reason at this time. Normalized audit schemas turn noisy events into evidence teams can actually use. Every service should emit the same core fields: event ID, timestamp, event type, category, severity, actor, resource, action, status, and metadata. This consistency lets teams query across systems, correlate an agent decision with retrievals and tool calls, validate required controls, and apply retention rules reliably. Use structured formats like JSON, not free text. Define categories for authentication, prompts, retrieval, tool use, approvals, data access, policy decisions, and outputs. Version the schema so future changes remain traceable and backward compatible. Audit logs are powerful because they preserve what happened, but that same detail can turn them into a shadow database. Prompts, tool arguments, retrieved documents, tokens, customer identifiers, and regulated data can all leak into logs if logging is too broad. In agent systems, the risk grows because each tool call may carry sensitive context. The goal is not to log everything. It is to capture evidence that supports investigation, minimize sensitive fields, protect log storage rigorously, and retain records only as long as needed. Protect sensitive data during log creation, not after collection. Redaction works best when the value is not needed. Mask passwords, keys, or most of an account number. Hashing helps when teams need correlation, such as recognizing the same email across events without storing the email itself. Tokenization fits cases where authorized systems may need to recover the original value through a controlled vault. The key design choice is reversibility. Protect data as close to the application as possible, so downstream pipelines, storage, and analytics never receive unnecessary secrets. Privacy-aware logging is not solved by masking a few fields. Treat logs as sensitive data products with their own governance. Limit who can read them using role or attribute-based access, because logs often reveal behavior, identifiers, and system decisions. Keep them only as long as justified by legal, regulatory, forensic, or operational needs. Where risk differs, separate high-sensitivity audit records from routine telemetry so controls can match exposure. Finally, review log content on a schedule. Look for over-collection, unexpected personal data, and policy drift. Then refine what you collect, protect, and retain. An audit trail is only useful if people can trust it after an incident. Logs should leave the agent's local environment quickly and land in a protected, centralized store. Once written, records are appended, not edited or deleted, preserving the sequence of events. Access controls should be narrow. Services can write what they need, reviewers can read what they need, and administrators have limited change authority. Separation of duties closes the insider gap, so the same team running the application cannot silently rewrite the evidence. Strong audit trails do more than store events. Each record can be digitally signed, proving who produced it and whether its contents changed. Each event can also include a hash of the previous event, creating a chain. If someone edits, deletes, or reorders a record, the hashes no longer match and the break becomes visible. Trusted timestamps add another layer, helping investigators reconstruct sequence with confidence. The operational point is simple. Integrity checks should run routinely, and teams should practice using them before the first real investigation. Secure audit trails turn agent activity into trustworthy evidence. Capture who acted, what was requested, which tools ran, what decisions were made, and the final outcome. Protect sensitive fields with redaction, hashing, tokenization, access controls, and retention rules. Preserve integrity with append-only, signed, centralized logs. Next, these records can power monitoring, alerting, incident review, and continuous posture improvement.